Hi, my name is Victoria. Today I'm going to be going over a very important biology concept called the central dogma. And it is the process where DNA creates mRNA through transcription, which then goes through translation to create a protein. And this is so important in our bodily functions because it makes literally everything in our body from enzymes to structural proteins. So basically everything, which is why it's so important. And so let's begin. The way I like to teach the central dogma is using the analogy of a recipe book. Like let's say we're making a cake. So let's see. DNA has these 4 bases and is located in the nucleus. And DNA is like this master recipe book. You don't want to take the whole book into the messy kitchen. It's just too valuable. So instead, you make a copy of just the recipe that you need, like just the small part of the book, and you turn it into this recipe card. So that copy or recipe card is mRNA right here. And the enzyme RNA polymerase is like a scribe to take the instructions from DNA to make it into this smaller but also extremely important version. And then the thing is also with mRNA, it could also go through a process called splicing. And that's basically where we could say, oh, I don't want these instructions. I don't want these instructions. I'll keep these. So it's subject to that, those little alterations, but only in eukaryotes. So then we can go into translation. It is basically time to bake. So that recipe card or RNA goes to the kitchen, the ribosome. The ribosome is the chef that reads the instructions of the RNA 3 letters at a time. These 3 letters are called codons. And each of these codons encode for an amino acid. Like let's say, for example, AUG makes methionine. Then there's transfer RNAs, tRNAs, who are delivery people, and they bring the right ingredients or the amino acids, and they bring it to this bowl, they bring it to the chef, and they mix it around and attach it to each other and all that fancy stuff in different mechanisms. But again, these tRNAs bring amino acids which are made from codons, which are 3-letter codes from mRNA. So once we're all done with that mixing up, we make our nice cake over here, or our protein. And it's made of amino acids, like I said, and those different amino acids, those different patterns of amino acids make different shapes, and they take on different roles. Their structure determines their function. So essentially, to wrap it up, the central dogma is DNA to RNA to protein. DNA is the recipe book, RNA is the recipe card copy, and proteins are the final cake. And different enzymes like RNA polymerase, splicing enzymes, are the helpers that make sure the process runs smoothly. So that's how the instructions in DNA become the working proteins that keep us alive.